Good morning, one and all. Today my TikTok topic is progressive waves, and this topic basically come across that aerodynamic structures. And basically we discuss about those four parameters in which that first of all definition and parameters, equations, and for example solid questions. And basically definition about the progressive waves. Distributed energy from one point of source to surrounding area. They move energy in the form of vibrating particles or field. There are two types of waves, progressive waves. There are two types in progressive waves. These are transverse waves and longitudinal waves. And transverse waves, the waves propagate in the direction perpendicular to the direction of vibration of particles. The waves propagation in the form of crest and trough, whereas crest are upper part and trough are bottom part. Examples of the wave transfer waves are vibrating of string, light, and water. Basically, we come across a figure as shown in which we are taking x-axis as distance and y-axis as displacement, and upper part is known as crest and bottom part is known as trough. And longitudinal waves. The waves propagated in the direction parallel to the direction of vibration of particles. The waves propagation as comparing and rare fractions. Examples of longitudinal waves are sound waves and earthquake waves. Basically, we are able to observe a graph in which they are taken x-axis as distance and y-axis as density. There is a comparison of a ray, and the dotted line is denoted as normal density. And wave parameters. In wave parameters, first come across the amplitude, the maximum displacement of a vibration particles from equilibrium position, and its SI unit is meters. And basically the amplitude is taken from center of the trough and center of the crest, which is taken by equilibrium in both top and bottom positions. And second one is period, the time taken to complete one full cycle, and it is denoted by the second. Basically we can able to observe a graph as shown in the figure in which there is a T indicates the period which completes one of the full cycle. And third one is frequency, the number of cycles per unit time is known as frequency, where F equals to 1 by T. F is denoted by the frequency and its SI units as hertz or second inverse. We can able to observe a graph as shown in the figure where the period can complete the one of the oscillation in which the maximum distance of the trough and maximum distance on one end of the trough to other end of the trough is taken as the frequency, and it is also taken as time t. And fourth one is angular frequency, omega. Angular frequency, it is denoted by the omega, where omega is equals to 2 pi by t, where frequency equals to 1 by t, and generally we can able to write it 2 pi f, and it is SI units are radians per second, where you can able to identify a graph as shown in the figure. There are two waves as traveling one over the other, and we can able to identify the x-axis is taken as a time and y-axis is taken as position. In this that we can able to identify there are two different colors which are red color and the blue color, and higher angular frequency and shorter period, and lower angular frequency and longer period. This is the difference of the waves we can able to identify. And fifth one is wavelength, and it is denoted by the symbol lambda, the length along the direction of a propagation between two corresponding points of the same phase. It means that the one end of the crust to other end of the crust, the distance is taken as the lambda, and it is also known as wavelength, and its SI unit is meters, where you can able to identify the graph as shown in the figure, where x is taken as a distance and y-axis is taken as a displacement, where lambda is the distance traveled from one of the trust to other end of the trust. And Sixth one is the wave number, and it is denoted by the k, where k equals to 2 pi by lambda, where lambda is the wave length. S7, it is radians per meter per second. We can able to identify a graph as shown in the figure, where it is known as displacement distance graph. And seventh one is phase, where the phase means the distance of one point to another point, in which we are able to identify that a graph where there are A, B, C are denoted and the other dot points are denoted, where A and B are in phase, which means they are in one of the propagation path, and B and C are in anti-phase. Here phase difference is denoted by the symbol phi, and clearly in the phi there is a one of the formula phi equals to 2 pi by lambda into x1 minus x2. And the wave equations are wave moving in positive x-axis. There is a one of the generalized equation where that y of x comma t equals to a sin omega t minus kx plus phi. Or another way also we can able to write y of x comma t equals to a sin of, in the place of omega we can able to interchange the omega t and the kx, and the generalized equation is a sin kx minus omega t plus phi. And also there is a wave moving in x axis in backward direction, and basically we have discussed in the before it is forward, where in backward y of x comma t with respect to time is sin of omega t plus kx plus phi. And also we can able to write in another form y of x comma t equals to a sin of kx plus omega t plus phi. Note, where a equals to amplitude, omega is the angular frequency, and k is the wave number, and phi is the phase angle. There are velocity of a particle, it is denoted by the vy, and by able to differentiating we can able to get dy by dx, and by using the generalized equation we get that a omega into sin omega t minus kx plus phi. And velocity of a propagation, the distance per unit time made by waves as it is propagates in medium, where v equals to f lambda. Propagation velocity density on a medium in which the wave propagates. Velocity is a stretched string, where it is denoted by v equals to under root t by mu, where t is tension, mu mass density, or mass per length. There is a graphical representation of the wave in which it is taken by distance in time graph. Y of x comma t equals to a sin omega t minus kx. This is the equation curve. And also we can able to identify another curve where there is a slight difference between the sign of in the before it is the, and y of x comma t equals to a sin omega t minus k into x. There is a basic example you can able to solve. The question of the propagation is given as y equals to 0.3 a sin 5 pi x plus 200 pi t, where x and y are the meters, t is second, determine the amplitude, frequency, wavelength, and velocity, where a equals to 0.3, it is amplitude, and angular frequency equals to 200 pi, and wavelength is k equals to 5 pi. By using the wavelength where k equals to 2 pi by lambda, by solving the equation we finally get lambda is equals to 0.4. By another angular frequency where omega is equals to 2 pi by t, where omega is given 200 pi, whereby further solving we get the t equals to 0.01 second, and the frequency equals to 1 by t, it is 1 by inverse of the time, so f equals to 1 by 0.01, and finalized f equals 100 hertz, and velocity v equals to f into lambda, where f equals to 100 hertz and lambda equal to 0.4 meters, where v equals to 100. Thank you.